Hello, in today data structure, the binary tree stands out as one of the most essential and widely used tool. Each node in binary tree can connect to at most two child nodes, usually referred to as left and right children. Trees are especially powerful when we want to model hierarchical relationships, like representing a company structure, file system, or even certain decision-making process in artificial intelligence. To work effectively with a tree, we must we must have ways to visit or process its nodes. These methods of visiting nodes are called tree travels. The three most common ones are pre-order travels, visit the correct node, then left, then right, in-road traversal, then right, post-order traversal, visit left, right, then correct node. But there is a fourth one, level order traversal, and the first road, then its children, then their children, and so on, left to the right by level by level. This project is also known as Breadth First Traversal and is best implemented using a queue. In this project, we will build a binary tree class in Java, create a level provide and finally. And firstly, binary tree class, yeah, this is generic class, this one. And then static methods, t data, t node, t node, t node, this data, constructor for this. This this like defines a generic class binary tree and the angel brackets with t allow this class to work with any type of data, whether strings, numbers, or custom objects. For example, you can create a binary tree string or integer binary tree. Public static class node these methods the data. This is a nested static class named node representing each individual node in the binary tree. Let's break it down. T data, node T left right, node T data, this data. T data stores the value inside the node, node T left right represent the nodes and love children, and node T data. The constructor takes a value, assigns it to the node data. We make this class static because it doesn't need access to other binary tree instance. These methods private node t root and then binary tree data. This is root is a root is private variable that represents to top node of the tree. When we create a binary tree object, we must provide initial data that becomes the value of the root node. Yeah, these methods and set root sub-tree root and set right. That's the next method. And then these methods allows us to connect other binary trees as the left and right of the current tree. We pass a binary tree object as an argument and its root becomes the left or right child. It makes this makes it easy to build a full tree by combining smaller ones these methods. And then level order public class level order implements iterator and private queue not queue new linked list. The lower order class implements Java Boolean iterator interface. This interface requires two methods as next and next. And then we use a queue to keep track of which nodes to visit next in the correct order. We use linked list because it's it supports the queue interface and allows users to add remove elements effectively from both ends. And constructor iterator methods, yeah, these methods, when the iterator is greater, when the iterator is created, we immediately add the root node of the queue. If the root is null methods, we don't add anything. This step is crucial because it's the starting point of traversal. And has next methods. These methods, yeah, these methods returns true if there are more nodes to visit. The queue keeps track of what's next, so we just check whether it's empty. Next methods, public t next. Yeah, these methods. If has next row new no such element exception. Yeah. Firstly, not the current tuple. We first check if there is a next node. If not, we throw a no such element exception, which is a standard Java exception when an iterator has no more elements. Fully removes and returns the flag node in the queue. Then we check if the correct node has left or right children. If the correct node queue had correct left, equal right node queue at correct right methods and return correct data. If the node is a left child, we add if to the queue sum for the right child. Finally, we return the correct nodes and data so it can be printed or purchased. And